This is a problem that asks students to determine the most electrophilic site in the molecule that's shown. They were given a table of molecular orbitals, their energies and occupancy, and their LCAO coefficients. And so we're basically asking you to look at the structure and to be able to use information from LCAO coefficients and molecular orbital energies to find the most electrophilic site. But the approach that this student took is a little bit different, and so it's actually a very good demonstration of when you think you can use your chemical intuition and the pressure is on, go ahead and take some risks, especially if there are a limited number of reasonable guesses. The other thing that this student did right, as we'll see, is that she remained poised even under some very trying situations of technology. So she's loading up the problem and instantly she gets an error message to come up. There it is. And she pretty much just ignores it and goes on. The error message actually says that there was a panel that didn't show up at the very bottom of this, and at this point the moderators were informing the students that this particular problem was having a problem with that last panel. You can't see it right now, but it's at the bottom of this screen. Students were asked to try to reload the problem, and in just a moment after she realizes that that panel is completely blank, she goes ahead and tries to reload the problem, but once again you'll see that it doesn't load up. So there's the missing structure. It was supposed to appear in the Marvin sketch window. So she draws the structure, she draws it with care, she draws it accurately, and notice she actually draws the double bond correctly, so it's in the E configuration. So she adds the bromine, checks the double bond geometry, matches every atom with that of the J-mol, and is ready to begin looking at solving the problem. She realizes right away she has a good guess, and she takes a risk. Immediately she puts number 1 as the carbonyl carbon, a very reasonable good guess. She realizes she has quite a bit of time left. She just goes ahead, looks at the table, I think comes to the conclusion that she's got a good guess and this table looks like a lot of information, so why not take a chance and see what happens with that carbonyl carbon. She gives the table one more look, probably understands what's needed. As you'll see later, I think she realizes what approach could have been taken to solve this problem with the information that we provided. But at this point, I think she realizes that time is ticking and the best thing to do is probably to go with her gut intuition and take a risk and see if it isn't that carbonyl carbon with 2 minutes and 40 seconds remaining. So she decides to submit it. She gets an incorrect response, but she decides that all is not lost. She has some other good guesses. She knows that the double bond that is next to the bromine is also a position where there's going to be, at least by resonance, a positive charge, and the bromine is likely to be a better choice than the other double bond because the bromine is a electronegative atom and has some inductive electron withdrawing effects. So rather than use the table at this point, she goes ahead and takes her second guess and labels that, and she gets the answer right. So entirely by using chemical intuition, willingness to take some risks, with 2 minutes left, she decides that she's going to learn something at this point and see if there wasn't an alternative approach to being able to get that problem correct on the first try. So at this point, you'll see she goes ahead, looks at the table. The table has the usual kinds of information in it, occupancy and the LCAO coefficients for orbitals 19, 20, 21, and 22. You can see in just a moment she's going to go over and look at the occupancy list and find out which one of those orbitals is the lowest unoccupied molecular orbital. That's what she's doing now. She recognizes that it's molecular orbital 20 that has the pertinent information in it. So she goes back to her LCAO table, finds out which one of those is 20. There it is, it's the second column. And now she's scanning down that column to try to find which of those coefficients is the largest one. And you can see it's the 0.5 on atom number 6. It's carbon atom number 6. It has a big 0.50 2 coefficient right there, and that's the atom that she had labeled with the correct answer. So carbon atom number 6 in the JMOL gave her the right response. So what the student did right here is, again, take risks, use chemical intuition, and apply that to make some guesses when there were a limited number of choices that could be made.